Good day. Today we're going to deal with a 2023 past paper on patterns. So let's begin. This is 2023 November, grade 12. So they say given the arithmetic series 7, 12, and 17. So there is a difference between a sequence and a series. In a sequence, we're given commas between successive terms. But in a series, we're given addition signs. So a series is better when we want to find the sum of the terms. So in this case, they gave us a series. So now let's continue. So they said, given the arithmetic series, and they're given the stuff, then they say determine the value of T91. So usually they like asking for the next two terms. So first we'll find the difference and we'll just simply add in order to find the following term, which will be 22, and then add again in order to find the following term, which will be 27. But now in this case, we're asked to find T91, so that term is far. So if we're asked to find a far term, we definitely need to get the formula. So our A, which is the value of the first term, is 7. And our D, which is the common difference, is 5. Because the difference is common, hence it's arithmetic. So we're just going to use the formula. So Tn is equals to A. There is a shortcut for this, but I'm just going to use the normal way that most students use. So this is the formula. The shortcut is actually in grade 9. So it's what you have learned in grade 9, where you just say dn plus t0. So dn plus the term that would have existed before term 1. But anyways, I'm not dwelling on that. So if you didn't understand my statement, don't worry about that part. So let's just focus on this. So we're going to have Tn is equals to our A. So some students actually prefer writing Dn minus 1. So whichever way you prefer, it's okay. So our A is 7. So we're going to have 7. Then we're going to have n minus 1. And our D, our common difference, is 5. So just put it in brackets there. So our common difference is 5. Alright, so now we're going to have Tn is equals to 7. I'm just taking a long cut, but I'm just taking a long cut. We could literally get the answer immediately, but for the sake of some students, let me take a long cut. So now this is going to be 5n, and then now we're going to have 7 minus 5. 7 minus 5 is 2. And then every time we get the formula, so our formula is Tn is equals to 5n plus 2, just in case that one is not showing nicely. So let's test our answer. So every time you get your answer, please test it, because every time you test your answer, you will know the marks that you definitely have. So you will know a certain mark that you cannot get below in the exam. So let's test it. So let's just test the second term. Let's see if we substitute 2, will it give us 12? So because this is in position 2, so if we substitute 2, it's going to be 5 into 2 plus 2. And 5 into 2 is 10 plus 2 is 12. So it gives us 12. So that's how we know that the formula is correct. Alright, so Tn is equals to 5n plus 2. So now let's get the value of the 91st term. So we're going to say T91 is equals to 5 into 91 plus 2. And then this is going to be 5 into 91 is the same as 455. 455 plus 2, which is 457. So our answer will actually be 457. Yep, so that's the value of the 91st term. Alright, so we found the value of the 91st term, which was 457. Now in the second question, they said calculate the sum of 91 terms. So when they say calculate T91, you use Tn formula. But if they say calculate S91, you use S formula. So use the Sn formula. So because it's arithmetic, we have to use Sn for arithmetic. So it's going to be Sn is equals to n over 2. Then we're going to have 2a plus n minus 1 d. Again, some students write dn minus 1. There is absolutely no problem with that. So it depends on the preference. So now the term is going to be 91. So we're going to say it's going to be 91 over 2. And then we're going to have 2. Our a was 7. And then we're going to have plus 91 minus 1. And our common difference was 5. So we're just gonna have 5 there. All right, let's just type this in the calculator and let's figure out what we'll have. So the answer will be 2,112. So we have 2,112. So we found the answer of the second one. Let's move on to the third one. So far the answer of the second one is 2,112. So now the third question says calculate the value for which Tn is. So this will calculate the value of n for which Tn is equals to 517. So this time they're asking us for the term number because they gave us Tn, they gave us the value of the term. So now they're asking for the term number. So using our formula, we know that Tn was equals to 5n. So it was 5n. So it was 5n plus 2. So now we've got the value of the term being 517 because n is the term number and Tn is the value of the term. So we're going to have 517 is equals to 5n plus 2. And then when we take this to the other side of the equation, we're going to end up having 517. So it's going to be 157 minus 2 is equals to 5n. And then from here, 517 minus 2 is just 515. So we'll have 515 is equals to 5n. And every time something ends with a 5 or a 0, we know it's divisible by 5. So it's perfectly divisible by 5. So if we divide this by 5, it's the same as 500 divided by 5, which is 100, and then 15 divided by 5, which is 3. So it should be 103. So it means it's the 103rd term. So n is equals to 103. So this is calculate the value of n. So we got the value of n. Yep. So this is the answer. So alright, so it means the value of n that will give you 517 is 103. Alright, let's move to the following question. So the following question says, it says that the following information is given about a quadratic number pattern. So you're told that this is quadratic. So already we're aware that is quadratic, and you're told that T1 is 3. So in essence, we've got the value of the first term, which is 3. And then you're further told that T2 minus T1 is 9. So we're told that, so this is T2, and then we're told that T2 minus T1 is 9. So T2 minus T1, so this minus this gives us 9. So that's what they told us. And then they further told us that T3 minus T2 is 21. So we have got T3. So T3 minus T2 is 21. So it means this part is 21. So they gave you the first value of the first difference and the second value of the first difference. So it's easy to get T2. They just told you that this minus this is 9. So therefore it just means T2. So this is not the only way to get T2. So they told you that T2 minus 3 is 9 because T2 minus T1 is 9. So therefore T2 is equals to 9 plus 3, which is equals to 12. So we found the value of T2. So T2 is 12. So from there, let's just replace it first of all. So it means that this is going to be 12. So now let's get the value of T3. So T3 minus, so they just told you that T3 minus T2 is 21. So in other words, T3, so T3 minus 12 is 21. So it means T3 is equals to 21 plus 12, which should be 33. So it means the value of T2 is 33, or rather the value of T3 is 33. So we found the value of T3. So this is 33. Alright, so now the first question. So the first sub question says that show that T5 is 111. So we have got T1, T2, T3, but now we need to get T4 and T5. So notice this is a quadratic pattern, so we can find the second difference. So 21 minus 9, which is 12. So the second difference is 12. So it means it will be 12, 12, 12, 12 because the second difference of a quadratic pattern is always constant. So we need to find out, for us to get the value of the fourth term. So for us to get the fourth term, we need to find out what must we add to 33 in order to get the fourth term. So for us to get what we should add, for us to get the second difference, the third value of the second difference, we need to add 12 because that's the second difference. So we have to add 12. So if we add 12, we are going to get 33. So 33 is what we must add on this in order to get the next one. So it means that we're going to say 33 plus 33, which is 66. So that is the value of the fourth term. Now to get the fifth term, we have to find out what must we add on top of 66 in order to get this stuff. So in order to find out what we have to add the second difference. So if we add 12, we're going to get 45. Yep, that should be 45. And then finally, we're going to say 66 plus 45. So 66 plus 45 is 111. So it's triple one, just like what they asked us. So exactly as they asked us, they say show that T5 is triple one. So we've solved it. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. So now, the next question says, show that. So the next question says, show that the general term of the quadratic pattern can be written as this. So the first one, the first question was simple to solve. We solved it without the formula. But if you wanted to, you could also find the formula in the first question and show that T5 is equal to that, but it will be a long cut. So hence, they asked you this question after this. All right, so now they said, show that. So they said, show that the general term of the quadratic pattern is this stuff. So in order to get the quadratic pattern, we always say 2a is equals to the first value of the first difference. So therefore, it means 2a is equals to 12. So if we divide both sides by 2, we'll end up getting a is equals to 6. So it means a is equals to 6. And then for the second one, we say 3a plus b is equals to the first value. So it's equals to the first value of the first difference. So equals to the first value of the first difference. So 3a plus b is equals to 9. And we've already found a. We found out that our a is 6. And notice it's actually coming out. It's just the same as this stuff. So it means it's going to be 3 into 6 plus b equals to 9. So therefore it means it's going to be 18 plus b equals to 9. And therefore we're going to say b is equals to 18. So, or rather 9 minus 18. So it's going to be equals to 9 minus 18. And let's see what this is going to give us. This is going to give us negative 9. And this is exactly what they're asking for. So now we're left with C. So in order to get C, we say A plus B plus C equals to the first value of the pattern. So A plus B plus C is equals to 3. So it should be equals to 3. So now we found our A, which was 6, our B, which was negative 9, then plus C is equals to 3. So 6 minus 9 is negative 3. Negative 3 plus C is equals to 3. Then it's going to be C is equals to 3 plus 3 by taking that negative 3 to the other side. And then finally we've got C is equals to 6. Let's see if it corresponds. Well, it corresponds well. And then we can simply substitute because we know that Tn is equals to an squared plus bn plus c. So now we can substitute. Our a is 6. So it means that Tn is equals to 6n squared. And then our b is -9. So we just say -9n, and then our c is 6. So we have 6. And there we have it. So we have solved it. Just before we attempt 2.2.3, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. Alright, so in this particular question, they said show that the pattern is increasing for all n is a natural number. So they're saying whenever the term number, and the term number is always a natural number. So because the term number always starts from 1, so it's always position 1 or position 2, position 3, going onwards. So it is always a natural number. So they're saying show that it is increasing. So now notice it is a quadratic pattern. So this is the formula for the quadratic, for this specific quadratic pattern. Now notice this is a parabola, because in a parabola, notice that it is always going to be, so we have an squared plus bn plus c. So notice in a parabola, if a is positive, so if a is positive, the graph is a smile. But if a is negative, the graph is a frown. So in this case, already by looking at a, we can tell the particular shape of this graph. So this graph is a smile because a is positive. So we know it's a smile. So therefore, it means that it starts decreasing up until the turning point because it's a smile. So if it was a frown, it will start increasing until the turning point, then starts decreasing. So it will increase until the turning point, then it will start decreasing. But now it is a smile. So therefore, it means it starts by decreasing first up until the turning point, then it starts increasing. So it means that we need to find the turning point. So one of the ways of solving this thing is to find the turning point. So we need to find the turning point. Alright, so let's find the turning point. So to find the turning point is going to be x is equals to -b over 2a. So it's going to be -b, so it's -9 over 2a, so 2 times 6. So then this is going to be x is equals to 9 over 12. Yep, so 9 over 12, yep. Okay, so 9 over 12 in a simplified form should be 3 over 4. Should be 3 over 4, yep, it's 3 over 4. So it means that x is increasing because it means this is the x value of the turning point. So it's a smile, so it is the x value of the turning point, 3 over 4. So it means it is increasing whenever it's greater than 3 over 4. So now notice the term number starts from 1, 3 over 4, so the term number starts from n is equals to 1, but 3 over 4 is before 1, so it starts increasing even before it reaches 1. So by the time it reaches 1, it will continue increasing all the way. It will never decrease again. So it means that for all term numbers, it will keep on increasing. So this is how you write it. You say the graph, right, Tn is increasing for all, so it's increasing for all n is an element. So for all n is greater than 3 over 4. So you're telling them that when t is always increasing when n is greater than 3 over 4. So all you have to do is to find the x value of the turning point, and then when you find the x value of the turning point, you have to find out, is it decreasing before the turning point, or is it decreasing after, or is it increasing before or after? So it depends. So if the survey is the graph increasing, you have to find out, is it increasing before the turning point or after the turning point? So if it increases after the value of n is 3 over 4, then you'll tell them that Tn increases for all values when n is greater than 3 over 4. So this is not the only way to write it. You can even say Tn is increasing when n is greater than 3 over 4. So we also tell them that n, right, the term number always starts from 1 and above. So it's always 1 and above. That's the term number or the position of the term. So it's always position 1, 2, 3, 4. So that's what's happening. So you'll tell them that n is always greater or equals to 1, and also n. So when n is a natural number, because the term number is always a natural number. So first you'll tell them that it's increasing for all these values, and then you will tell them that n is greater than 1. Or if you want, you can even tell them in words. You can just say the term number. You can even tell them that the term number starts from 1 upwards. So you can even tell them that it starts from 1 upwards. So it starts from 1 upwards. So that's what you tell them. Okay, just don't mind my handwriting. Yeah, I'm just rushing, so hence it's like this. So you'll just tell them that the term number starts from 1 upwards. So therefore, after telling them that the term number is from 1 upwards, you can also tell them that n is an element of natural numbers, because that's what natural numbers mean. It starts from 1 going upwards. So you can tell them n is greater or equals to 1, or you can just simply tell them n is an element of natural numbers. So after telling them that the term number is 1 upward, you tell them that therefore therefore Tn is increasing for all values, for all n. So for all values of n where it's an element of integers, element of natural numbers rather. Yeah, so that's what you'll do. So that is one of the ways of solving it. There is another way of solving this stuff. So you have to understand calculus in order to solve this stuff using the other way. The other way to solve it is that whenever the graph is increasing, the first derivative is positive, and whenever the graph is decreasing, the first derivative is negative. So this is what you're going to do. So we have got a parabola. So you can just say let this one be, so you can say let it be x, let Tn be f at x. So you tell them that f at x equals to 6x squared minus 9x. So it's going to be minus 9x plus 6. Yep, that's what you will tell them. And then from there, we can now find the first derivative. So we'll find the first derivative. So this is going to be 12x minus 9. And then whenever the graph is increasing, the first derivative is positive. So if it was decreasing, the first derivative would be negative. So now in this case, we'll just substitute the first derivative must be positive, and then we solve. So then this is going to be 12x is greater than 9, and then when we divide both sides, we will get 9 over 12, which is, so we'll get 9 over 12, which is 3 over 4, just like what we got before. So it means that it's increasing whenever it's 3 over 4. But now notice, you'll also tell them again that the term number is always greater or equals to 1. Right? Because they also said it's increasing for all n is an element of natural numbers. Yep. So just by showing them this part, and also telling them that but n is greater or equals to 1, even before we tell them this, we just have to tell them that therefore f is increasing. So f is increasing for all. So you'll tell them it's increasing for all x is greater than 3 over 4. So when you tell them that it's increasing for this stuff, you tell them that but n is greater or equals to 1. Then you just simply say therefore f is increasing. Or rather you say Tn, because first we're talking about Tn. So you say therefore Tn is increasing for all n is an element of natural numbers. Yeah. So that's what they said. So show that the pattern is increasing for all and is element of natural numbers. Yeah, so this is not the only way to write this stuff. Yeah, so these are the two ways to solve it. Alright, so see you in the next video where I solve question 3. So if you enjoyed this video, please like the video and subscribe to my channel. Support me by sharing the video. And any questions you've got or any video you want me to make, please comment below.